On most world maps, Greenland looks so huge, almost the size of Africa. So I used to think that Greenland was one of the largest countries in the world. But in reality, Greenland is only about 1/14 the size of Africa. Just how much is Greenland exaggerated? Surprisingly, we can calculate the amount of distortion based on latitude using just the cosine function. Let's math travel into the scale factor formula behind the Mercator projection. Here is how Mercator projection works. Imagine wrapping the Earth in a cylindrical sheet of paper. A light shines out from the Earth's center, projecting the shapes of continents onto that paper. When you unroll the paper, you get the map we are all familiar with. This type of map preserves angles and shapes, which is great for navigation. But it comes with a cost. It distorts distances and areas, especially near the poles. Greenland is the poster child for Mercator distortion. Here's the cool part. There's a mathematical way to measure this distortion called the scale factor. It tells us how many times larger or smaller a distance on the map is compared to the real world, depending on latitude. This line here, that's the actual distance between 2 points on Earth. And this one, that's the distance between 2 points on the map. Divide the map distance by the actual distance. It's the scale factor, showing the ratio between the map distance and the actual distance. Let's derive a simple formula for it. Imagine 2 points at the same latitude theta. Their longitudes are lambda1 and lambda2, with a small difference d lambda. The unit of lambda is radians. The Earth has radius r. To find the actual distance between those points, we use the arc length formula. At latitude theta, the effective radius of the Earth is r cosine theta, so the circumference of that radius is 2 pi r cosine theta. The distance between the points lies along this circle. Therefore, the arc length, that is the actual distance, is this. But on a Mercator map, all horizontal distances are treated as if they are on the equator, where the radius is just r. So the map distance between those points becomes this. What's the scale factor formula? It's the map distance divided by the actual distance. So the scale factor is this. It is very simple. The scale factor is inversely proportional to cosine function. Try plugging in some latitudes. At the equator, cosine theta equals 1. So the scale factor equals 1. The map distance is the same as the actual distance. There is no distortion. At 60 degrees latitude, cosine theta equals a half. So the scale factor equals 2. The map distance is 2 times the actual distance. Everything is twice as large at 60 degrees latitude. Here's the graph of the scale factor. As the latitude increases, the distortion skyrockets. Now back to Greenland. Greenland stretches from about 60 degrees to 84 degrees north. Plug in those values into this formula. The scale factor ranges from about 2 times to over 8 times, depending on the spot. At an average latitude of 72 degrees, the scale factor is around 3.24. Remember, the ratio of the areas is proportional to the square of the ratio of the lengths. On average, Greenland's area is inflated by a factor of 10. A simple cosine function can reveal how distorted our world maps really are. Let me know your latitude. I'll tell you how much your area is distorted on a Mercator map. Did you enjoy math traveling? Please subscribe for the next trip.